Good evening, students. This video is of economics and for class 12th. We are continuing with the elasticity of demand chapter. Now today in this video, second method of calculation of price elasticity of demand we will discuss. Total expenditure method is the second method. So in total expenditure method, basically total expenditure will be equal to what? The price of the commodity multiply the price as in rate per unit, price per unit, multiply by the quantity of the product bought. So total expenditure in short we can write as TE, P we can write as P, and quantity as Q. So this is the simple thing, very simple thing. Now here children just pay attention. Elastic demand, I'll simplify the thing. Elastic demand will be in a case, where as the price falls, downward pointing arrow denotes fall in the price. Okay, so what happens? Total expenditure TE increases when the price falls but total expenditure increases. Okay, or you can say price, or in brackets I'll put that, price rises. Okay, and as a result of that total expenditure falls. Simple way of putting it in a symbolic form, we say that there is elastic demand, and elastic demand, in this case EP, that is price elasticity of demand, is going to be greater than 1. So remember this. Instead of having lengthy definitions, in symbolic form this concept is finished. You can, obviously in the paper you have to write. Once you understand the concept, you can express in your words. Now then we move to second category, that is in elastic demand, and after that I'll elaborate by giving you demand schedule of the 3 cases. Now children, in this case, as the price falls, total expenditure TE also falls. Yeah, in that, if the price is falling but the total expenditure is also falling, we say that the demand is inelastic. Or we can put it that way, that if the price rises, the total expenditure also rises. Means there's a direct relationship between the price and the total expenditure. In such a case, we say that the demand is inelastic, and in case of inelastic demand, EP will be lesser than 1. I hope this is clear. Then the last case is third one, unitary elastic demand. Unitary elastic demand, which means EP, you already know the basics. In previous video I have done. In this, unitary means 1. EP is equal to 1. When would that happen? Yeah, so that would happen when whether the price rises or it falls. Upward pointing arrow denotes increase in the price, or this is or. Downward pointing arrow denotes decrease in the price. What happens? It doesn't make any difference on the total expenditure of the consumer. Total expenditure remains the same, constant, and constant I denote with a horizontal arrow. Yeah, so in this case we say that it is unitary elastic demand, or price elasticity of demand is equal to 1. So now in total expenditure method, I'll denote with the demand schedule. First case, elastic demand. Price is here, I'm reading here, I'm just marking. If the price is rupees 60, the quantity demanded is 10. So what is the total expenditure? Multiply 60 into 10 gives you how much? 600 rupees. If the price falls to 50, yeah, I'm reading over here, and the quantity demanded by the consumer is 13. second row. Okay, so what is the total expenditure incurred by the consumer? 50 into 13 gives you 650. So what's happening? As the price has fallen down from 60 to 50, just analyze what is happening to total expenditure. Total expenditure has increased. So which is this case? This is the first case. So we say that in this case EP will be greater than 1. It's the case of elastic demand, and in such a case, children, we will have a flat demand curve as shown over here, that you can make. At 60 quantity demand, it is 10. This is price and quantity. I'm not mentioning total expenditure anywhere. Okay, so the idea of making a demand curve is that we in the case of elastic demand, we have a flatter demand curve, which indicates that a big change in price, a small change in price causes a big change in the quantity demanded. As is evident over here, 60 to 50 the price is falling. This distance is lesser, but the quantity demanded has, increased from 10 to 30. So as you can see, the distance on quantity, the change in quantity is bigger as compared to the change in the price. We move to the second case. In elastic demand, there's a demand schedule presented over here. When the price was rupees 60, the consumer was buying 10 units quantity. So how much was he spending? 60 into 10 makes it rupees 600. Yeah, I'm indicating with tick mark where I'm reading so that you can focus over there. When the price fell down to 50, the consumer, the product became cheaper. So he has increased the consumption. The consumer has bought 11 units. So 50 into 11 makes it, he's spending a total of 550. 5 11 is 55 and 10. So just go by the basic symbolic form which I told you here. What's happening when the price is has fallen down? What is the effect on the total expenditure, children? Total expenditure was 600. From 600, it has fallen down to 550. Total expenditure has fallen down. Means it shows a direct relationship between the price and the total expenditure. And I told you, just let's go back and see. This is what the second case is of inelastic demand. Yeah, price falls and total expenditure also falls. So it's easy. So in this case, obviously, because it is inelastic demand, yeah, so EP will be lesser than 1. And in this case, I told you earlier, in case of inelastic demand, you have to draw a steep demand curve. When you make a steep demand curve, automatically you'll get the distance in the price, new price and the old price, and distance between this gap I'm talking about on the x-axis quantity. Logically correct. How? In elastic demand, what do we want to say? That the change in the price is big. A big change in the price is causing a small change in the quantity demanded. So that is evident over here. If you see this gap, yeah, price has fallen down from 60 to 50. This gap is bigger than this gap. Quantity demanded has increased, but very small. We move further. Third case, unitary elastic demand, where EP is equal to 1. In this case, let's focus over here in the first column. 60 was when the price was rupees 60, the consumer was buying 10 units. Price has fallen down to 50, and the consumer has started buying 12 units. Let's calculate the total expenditure. 60 into 10 gives us 600 rupees. Total expenditure was 600. Then at 50 price, multiply by what quantity he is buying? 12. So 5 12 is 60 and 10, 600. That means price has fallen down, yeah, but total expenditure, is there any change? No change. It's constant, which I am denoting with a horizontal line. So which is this case? I just told you, this is the case of unitary elastic demand. Means I'm encircling it EP, that is the symbol for price elasticity, is equal to 1. And in this case, you can plot it on your own on on a graph, but remember I told you what is the rule. The rule is whenever it is unitary elastic demand, you get a rectangular hyperbola. The demand curve is, in mathematics you call it, mathematically speaking, it's called a rectangular hyperbola shape. Revision: it approaches the y-axis and the x-axis, okay, but never touches them. So with that I conclude this session. Hope it was clear. Just take a screenshot of this symbolic form and take a screenshot and revise.